Lesson 3 deals with number sequences and number patterns, and I have selected some problems outside of the text that illustrate some of the formulas in this chapter. The first problem: find a formula for the nth term of the odd numbers. Well, as you know, the odd numbers are the sequence 1, 3, 5, 7, 9, and so on. This is an arithmetic sequence because we add 2 to go from term to term, which makes 2 our common difference, or in the formula, D. The general formula for the nth term looks like this. A sub n is a sub 1 plus n minus 1 times d. Well, the first term here is 1. N minus 1, and then times our common difference 2. Doing a little bit of algebra, we're going to distribute the 2 here and write this as 2n minus 2, and finally 2n, and then we have a negative 2 and a positive 1, which is minus 1. So here's the formula for the odd numbers. Now, let's just verify that the formula works. The first odd number should be 2 times 1 minus 1, which is just 2 minus 1, or 1. The second odd number should be 2 times 2 minus 1, and that's 4 minus 1, which is 3. The third odd number would be 2 times 3 minus 1. That's 6 minus 1, or 5, and so on. So this formula does indeed fit. Second problem here. Find the missing terms of the arithmetic sequence 10 blank blank 70. Well, this sequence has 4 terms. The first term is 10. The second term we don't know, but the second term should be the first term plus the common difference. The third term we don't know, but the third term should be the first term plus 2 times the common difference. The fourth term is 70. The fourth term should be the first term plus 3 times the common difference. This gives us an equation to solve, because 70, the fourth term, should equal 10 plus 3 times the common difference. We can solve for D. Subtract 10 from each side. 60 is equal to 3D. Divide by 3. 20 is our common difference. Now, with that in mind, that second term is 10, the first term, plus 20, the common difference, 30. The third term is 10 plus 2 times D, and that's 10 plus 40, which is 50. So our sequence is 10, 30, 50, 70.
Okay.
The third problem in our introduction to sequences. For the arithmetic sequence, -4, 1, 6, and so on, which number term is 61? Well, for this, we're going to refer to our general formula. A sub n is a sub 1 plus n minus 1 times d. Now, what's d? Well, to go from term to term, how much are we adding? Well, add 5 to -4, that'll give us 1. Add 5 to 6, that'll give us 1. So then D is 5. The first term is -4, so I'm going to write that here. N minus 1 times 5. Well, we don't know what number term it is, but we do know the term itself is 61. Here's an equation where the unknown is n. N is the number of the term. So let's solve this equation. 61 is -4 plus 5n minus 5. 61 is 5n minus 9. Add 9 to both sides. Add 9 to 61. And that is 70 equals 5n. If we divide by 5, n is 14. So 61 is the 14th term in this sequence. The next problem is involving a geometric sequence. Find R, the common ratio, and the fifth term of the geometric sequence that begins 4, 12, 36, 108, and so on. Well, an easy way to find the common ratio is to divide two consecutive terms. 12 divided by 4 is 3. Similarly, 36 divided by 12 is 3. And 108 divided by 36 is 3. Now that we know that the common ratio R is equal to 3, we can easily compute the next term. The fifth term would be the one following 108, so the fifth term would be the fourth term times R, which is 108 times 3, and that's 324. So there's the fifth term in our sequence. The last problem we're going to look at, we have a sequence that is neither arithmetic nor geometric, but it does have a formula, and what we want to do is this. Write the first 5 terms of the sequence given by the formula, where a sub n represents the general nth term, and a sub n is equal to n over n squared plus 1. So the first 5 terms. The first term, a1, or a sub 1, we're going to replace each n by a 1. So it's 1 over 1 squared plus 1, and that's just 1/2. A sub 2, 2 replacing each n, so 2 over 2 squared plus 1, and that's 2 over 5. A sub 3 is 3 over 3 squared plus 1. 3 over 9 plus 1, or 10. A sub 4 is 4 over 4 squared plus 1, and that's 4 over 16 plus 1, or 17. And the fifth term, a sub 5, is 5 over 5 squared plus 1, and that's 5 over 25 plus 1, 26.